Okay, so we're going to talk about angles and circles today, and looking at your notes, we're going to be talking about angles that have vertices in the center, on the edge of the circle, in the circle, and outside the circle. Today we're just going to focus on central angles, so angles that have vertices in the center, and then inscribed angles where the vertex is on the edge of the circle. So let's look at our central angles first, like you looked at your vocabulary the other day. A central angle is an angle whose vertex is at the center of the circle and its two sides are radii. Okay, so let me explain that with a picture. We have our angle here. We have angle ABC. We can see that B is the vertex, it's in the center of the circle. We can see that AB and BC are both radii, and that forms your central angle. We just talked about that angle, so we can know we name it angle ABC, with our vertex being the middle letter. The sum of all central angles, which means all the angles with vertices in the center, all are going to add up to 360. Okay, so let's break this picture down for a little bit before we talk about the relationship. We have angle ABC. It is going to correspond to arc AB. So you might want to get a marker out and mark that just like that in your notes. If not, that's okay. Circles are a little bit different because you're used to seeing angles that are linear, so 180 or less. But with circles, we can have angles that are over 180. So if you have a marker, get a different color, and you can mark that this right here in green is also the measure of an angle. It starts here at AB, goes all the way around, and stops at BC. Its arc that it corresponds to is major arc ADC. So we do have two angles there. They're going to add up to 360. So if we want to find the major arc or the major angle, we could say 360 minus the 84, and that would give us 276 degrees. Now, the relationship between the central angle and its corresponding arc is that whatever the central angle is, the arc measures the same exact thing. So ABC is 84, arc AC is also 84. The other side of this would be 276 for major arc ADC. So what you need to understand is that the measure of the arc formed by the endpoints of a central angle is always equal to the degree of the central angle. They'll always match up. If you know the angle, you know the arc. If you know the arc, you know the angle. So we just found arc AC, minor arc AC to be 84 degrees, and we found major arc ADC to be a 276, and we can check together they would add up to 360. So let's do some practice questions here. Before we even look at any questions, we're going to always start with our picture. And we're going to look for things that we see and notice. I see from here to here is 90 degrees. So we know those two angles would add up to 90 degrees. It's not bisected, so we can't assume that. But we do have here two intersecting lines, which means we have vertical angles. So if we know that TUS is 19, then we also know that UR is also 19. So we can go ahead and put our 19 there, which means arc QR is 19 because we have all central angles. We can go ahead and mark arc TS is 19 also. So if QUR is 19, we can subtract from 90 degrees with our 19, and that's going to leave us with 71 degrees to go in this angle, and also that arc. Okay, a couple other things we're going to think about here is if this is a diameter, remember diameters are going to split the circle in half. So if the top half equals 180, we know that this angle has to be 90 also. The bottom part of that also equals 180. So if we know part of it's 19, we can subtract the 19 from 180, and we will get 161 as our missing piece. If you want to do a quick check, all you have to do is add all those angles or add all those arcs together, and you should get 360 degrees. So now let's answer some questions based on that. So PQ, I'm going to highlight in green. PQ is arc PQ here. We can see that that is 71 degrees. Okay. The next one is SR. So because it's a minor arc, it's 2 letters, we have to look for the shortest distance between S and R. So the shortest distance is from here to here, which we can see is 161. The next one is 3 letters, so we have to decide, is it going to be a major arc or is it going to be a semicircle? So let's highlight it. Q to R to T, and because it's an arc, we have to stay on the edge of the circle. We cannot jump through the circle. You have to stay on the edge. So we're going to start at Q, go to R, and keep going till we get to the T. We can see that that's over halfway because that passes the diameter. So we know that half the circle is 180. So I can take the 180, and then I can add that extra 19 to it, and that would give me an arc of 199 degrees. Okay, I'm going to change colors here to blue for my highlighting, and now we're looking at PSR. So again, I have to decide, is it going to be a major arc or a semicircle? So I can highlight to C, and I'm going to do this one in blue. So I'm going to start at the P, go from P to S, and then all the way to R. So we can either add up the 90, the 19, and the 161. We could do 180 and 90, or we know that's everything but this right angle here. So we could just take that away from 360, which actually saves us a little bit of time. And so that would give us 270 degrees. But it's okay if you wanted to add them all up. There's no harm in that. We'll all get the same answer. Okay, the last one here is arc PS. We can see the shortest distance from P to S. I'm going to highlight that in, let's say, yellow. So from P to S, start at P, go to S. I'm working in yellow. We can add those two together. 90 plus 19 gives us 109. Okay, let's jump to the other side. We can see that now we're adding some variables to it, but the rule is still the same. They're all central angles. We know they all add up to 360. I notice here that we have a right angle, so we can go ahead and say that that would be 9 degrees. We don't have to worry about that one. So if I take that 9 degrees out away from the 360, we know that we're left with 270 degrees for these 3 angles here. So when I go to combine my like terms, I'm going to say 8x plus 21x minus 12 plus 10x plus 9. And I'd just like to vertically line up my like terms. 21 plus 10 gives me 31, plus 8 gives me 39 x's. Negative 12 plus 9 gives me negative 3. And we said a while ago that that's going to add up to 270 degrees because we're not including the 90 in that count. If we were to solve that equation, we would add 3. So 39x equals 273. Divide by 39, and x would equal 7. Okay, so now we can kind of focus on our picture again, but we need to take that 7 and plug it in so that we know exactly what our angles and arcs are. So if I start at the top here, 8 times 7 gives me 56. 21x, so 21 times 7 minus 12 gives me 135. 10 times 7 plus 9 gives me 79. And again, if you want to check and add those 4 numbers together, you should get 360 degrees. So let's find our missing arcs here. So we're looking for WX. It's a minor arc, so the shortest distance. So W to X there would give us 135. Make sure you're putting your degree symbol. The next one is another minor arc, so the shortest distance possible between W and Y. So the shortest distance there would be those two. So we would have to add the 90 and the 56. And that would give us 146 degrees. We We have another minor arc because 2 letters, so the shortest distance between y and x, that's an easy one to see right there. We know that that's going to be 79 degrees. And our last one here, we don't know again if it's major or minor. Major or semicircle. But if you look at your circle, do you have any diameters? If you don't have any diameters, there's not going to be a possibility for a semicircle because a semicircle starts and stops on a diameter. So we know this is going to be a major arc. Let's go ahead and trace it out. We start at V, go to X, and finish at W. So everything except for the 56. So you have a couple of options. You could add the 90, the 79, and the 135, or you could just subtract the 56 from the 360, and that would leave you with 304 degrees. Okay, so those are central angles. At the bottom, on your notes, by the word center, on that tab there, I want you to write this formula for me. Angle equals arc. That way, when your foldable is just flat, you can see all your formulas that we're going to use for this. Okay, just remember, if you know the angle, you know the arc. You know the arc, you know the angle. The vertex is in the center. This is always going to work. Okay, so let's move on to the next one and talk about our inscribed angles. You learned the other day through your vocabulary activity that inscribed angles have an angle where the vertex is on the circle. And instead of the sides being radii this time, you can see in the picture here that the sides of the angle are going to be chords. An intercepted arc is the arc that lies between the endpoints of an inscribed angle. Okay, so let's talk about what that means. Go ahead and take your marker or highlighter, whatever you have there, highlight that angle, angle ABC. And we know that it's intercepted arc or corresponding arc. I may say it 2 different ways, but it's the same thing, is arc AC. Now this one's different. It's not like a central angle. They don't have the same relationship because we scooted the vertex, so we pulled that angle back further, and so it has to open up a little bit more to create that arc. So what we're going to do is take the arc and cut it in half. Let me make that better. So, for instance, if we know arc AC is 100, then angle ABC has to be 50. If arc AC is 80, then the angle would be 40. Or if I flipped it around and said angle ABC is 30, then the arc would be 60. So we're either going to be multiplying by 2 or dividing by 2. So the last blank there is the measure of the inscribed angle is equal to half the measure of its intercepted arc. All right, so now let's look at when we intercept a diameter. So if I zoom in here on this picture, we can see that angle BAC opens up to a diameter. Well, we know when it opens up to a diameter, it creates a semicircle. And so that means our arc is 180 degrees. And if the angle is half the arc, then that angle has to be a right angle. So anytime an inscribed angle is opening up to a diameter, you know it's going to be a right angle. Which means BAC would equal 90 degrees. All right, let's look at some examples here. So let's start with the first one. The first thing I want you to do, especially till you get really familiar with this, is I want you to put the formula. We're going to abbreviate. We're going to say angle equals arc divided by 2. So we've got our angle symbol and our arc symbol. And we're just going to substitute what we know for angle and arc. Well, looking at our picture here, I'm going to highlight my angle, and I'm going to highlight the arc that corresponds to it. And that might be a good idea for you to do also in your notes. Grab a marker. We don't know anything about the angle, so I'm just going to substitute X in for angle. But I do know my arc is 62, and so I would plug that into my formula, which makes this really easy. 62 divided by 2 gives me an angle measure of 31 degrees. Looking at the next one, again, I'm always going to start with focusing on my angle and highlighting it. We know that this is the arc that corresponds to it, so I can set up my formula, angle equals arc divided by 2. I now know that 8x minus 9 is my given angle here. And the arc that they gave me was 158. So my advice would be to start with dividing by 2. So we would say 8x minus 9 equals 79. Add the 9 over, 8x equals 88. Divide and x equals 11. And the question is saying solve for x, so we are done. All right, last one here. When I look at my question, I'm going to really focus on some symbols. I have my given angle here, which I can put on the picture, but I don't have to. I also have my given arc right here. So those are the two pieces I need for this problem. So angle equals arc divided by 2. Let's sub in what we know. We know the angle given was 6x plus 21. And the angle given is right here at FGH. It corresponds to arc HJF or FJH. Doesn't matter the order you say it as long as J's in the middle. And so we're going to replace what we know, the 17x minus 28 divided by 2. Okay, so this one, sorry, has x's on both sides. It also has that fraction that we have to take care of. So we're going to do the opposite and multiply both sides by 2. The left side, we actually multiply 12x plus 42. The right side, the 2's just cancel, and it leaves us with 17x minus 28. So move the 12x over, and that gives us 5x. Add 28 over, that gives us 70. Divide by 5, and x equals 14. Well, this one isn't saying find x. This one says to find arc FJH. Well, all I have to do is take the 14 and substitute it in to the 17x minus 28. And that would equal 210 degrees. So we can say the measure of arc FJH equals 210 degrees. Okay, that's an inscribed angle. You've got to make sure and pay attention and write those formulas down. Do that till you get really familiar with this. Don't just try to go straight to the formula. Not straight to the equation. Write the formula down. So the formula I want you to put down here on the bottom tab is going to be angle equals arc divided by 2. All right, we've got one more section for today, and then you're going to practice these types of questions, and then we'll do the other two next week. So this one is still an inscribed angle, but instead of the inscribed angle being made up of two chords, we can see the inscribed angle is made up of a secant and a tangent. And the difference here is your arc is right here for that angle. If I want to do the other side for angle 2, I would highlight that secant and that part of the tangent. And from B to C to A over here would be its corresponding arc. So now visually you can see that. If you want to pause and grab some markers and highlight yours the same, that might be a great idea. We know that the measure of angle 1 is going to be half. And we would look for its corresponding arc. It's a minor arc, so we would name it AB. 2 opens up to a major arc, but it's still half the measure of arc ACB. So still the same formula, nothing changes there. It just changes kind of how it looks. It doesn't look perfectly like a snow cone like the other ones did. All right, practice questions. Here we go. Let's look at our picture here. We were given an angle, so I'm going to focus on that first. Here's the angle, our secant and tangent. We can see that YZX is our corresponding arc. Well, I know from the formula, angle equals arc divided by 2, that if my angle is 151, what number divided by 2 gives me 151? And that would be 302 degrees, which would go here. So our question is, what is the measure of XY? Well, that wasn't the measure of XY because XY is a minor arc. So we have to focus on knowing what is this little piece right here. Well, we know that that blue minor arc and the purple major arc are the whole circle, and so that has to add up to 360 degrees. So we can take our 360 minus the 302, and that's going to equal 58 degrees. So we could say the measure of arc XY equals 58 degrees. All right, last one here. Again, we're going to focus on what we were given. We were given arc BED. It's not a diameter. There's no center point, and it's 192 degrees and not 180. We can see the arc that or the angle that it corresponds to is ABD. We talked about the formula, angle equals arc divided by 2. We don't know the angle, but we know the arc is 192. So 192 divided by 2 is 96, making this angle right here 96 degrees. Can do a couple things. The question is asking for angle DBC, which is right here in blue. We could find the other arc, divide by 2, but we also know based on our past knowledge that angle ABD, so this one right here, and angle DBC are a linear pair. So if we know one angle, all we have to do is take that away from 180, and that leaves us with our other angle. So we can say the measure of angle DBC equals 84 degrees. The last thing I want you to do is take our formula, angle equals arc divided by 2, and put that formula there. And so your focus today is, are you working with a central angle or are you working with an inscribed angle? And use your formulas based on that.